Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic. Today we will start fourth pattern, which is parenthesis and scoring. And you know, this is my favorite pattern ever. Why? Because this is very simple. You just need to check the valid parenthesis whenever the open bracket find its correct pair of closing bracket, and that too at the correct location. In starting you might feel bit difficult, but trust me, it's very easy once you learn. So let's do the very first question, and I hope most of you would have already done this. The question name is valid parenthesis. The thing is, as you can see, example number 1 and example number 2, okay, the question says you will be given 3 different types of brackets, and you have to say the particular string is valid or not. When a particular string is valid, when it finds its closing pair, and that too at correct location. Okay, so what did I said? Suppose we have example this, okay, and another example this. Which one is correct, first or 2? Definitely first. Why? Because see, in both the cases, for both open brackets we have closing brackets, but in first condition the position is correct, in the second the position is not correct. So position matters. How? Whatever is a nearest open bracket na, after that you should have closing for the same, correct? Yes. So you encountered a small open bracket, square open bracket, and now if you find any such closing bracket, that should be matching pair for the nearest one, the top one. I hope now you can relate to the stack, like why stack data structure we have to use. But first we'll check the brute force code, okay? Like how can we think for this? But no matter we write brute force or optimized, first we have to come up with the test cases, what type of test cases we have to check for, so that we can write the code for us. So I have taken 3 examples for you. First, open, okay? So, okay, you find at ith location you have open. So definitely I plus 1, if it is a closing bracket, it should be from the same family. Means if ith is open, I plus 1 is closed. This is not from the same family, correct? Similarly, if ith is open and I plus 1th is closed, now we can say this is from the same family, correct? So hence, if ith location is valid, like is open bracket, and I plus 1 is closed bracket, for sure they should belong to the same family, otherwise return false then and there. Because if the current brackets are not matching, it means it's not a valid string, right? So you have to return false then and there. Very first condition. But in this case, ith is open, I plus 1 is closed, and that too from the same family, so we can say yes, it is correct. Correct? So now definitely this we should have deleted from this string. Yes, as a string is immutable, so please use string builder here. Okay, you can convert into string builder. Now ith location was at 0th location, so we know as ith location is at 0th location, so for sure we have nothing towards the left side. Okay, so we can simply do what? 2 jumps. Can I say I plus plus? Yes, correct. Okay, now we are at here. Okay, anyhow, after deletion you have this na, like means you have a string like this, correct? So earlier also I at 0, now also if you don't touch, obviously this will point to same, so you don't need to take 2 jumps, I guess. Okay, keep the I at same location. Okay, why? Because now the string length has been decreased, correct? Again, I is open, I plus 1 is closed. Are they from the same family? Yes. Okay, delete. Now string will become empty. Okay, and now you can say if the string is empty or string builder is empty, you can say it is a valid string, right, with valid parenthesis. Okay, now let's talk about example number 2. Okay, let's talk about example number 2. We have open, yes. Is it like I plus 1 is also open? No. So we will simply do I plus plus. Okay, if we have continuously open, move ahead, do I plus plus. Okay, now I is open, I plus 1 is closed. Yes, so now there is a possibility for true or false, like if the I plus 1 closing bracket is not matching pair, we will return false then and there. So I is open, I plus 1 is closing. Are they from the same family? Yes, so we will delete. Correct? Now what is the location for I? 1. Okay, it is greater than 0. So I can definitely say there are some leftover pairs behind which has, like, for which we have not found the closing or open bracket, like whatever. Okay, so what we'll do, instead of going ahead, we will do I minus minus. Now the string length has been 1. I is already here. I plus 1, there is no such index. So you will come out of the for or while loop, whatever you have written, and you will see okay, string builder has 1 left. That means for this open bracket, you have not found any such close bracket. So can I say if at the end my string length is empty, it is true. And at the end, if the string length is not empty, means it is false. Now let's take the third condition. In third, you found open bracket. Yes. So I is open, so I plus 1 is closed. Yes. So again, if this is valid, so we'll delete. Okay. So in total, string only have single character that already I is pointing to. I is a closed bracket. So we'll simply move ahead I plus plus. When we stop, when ith location, like ith index value is open and I plus 1 is closed. Remember that. So in this will come out of index. Now at the end, again this string builder length or string length is not 0, means we have leftover brackets for which we have not found the correct pair. So at the end we can return false for this case, false for this case, and true for the very first case. Correct? Yes. But if we will write the code for this, what can be the time complexity for this? See, anyhow we are iterating only one time, so O of n. But when we are deleting anything from string builder, correct? Because string builder is nothing but character array. So whenever we delete anything from array, leftover, like any elements towards right side shift themselves towards the left side. That further takes O of n time complexity to rearrange itself. Okay, so that is the reason the total time complexity will be O of n square. But if you see the constraint here, s length is 10 power 4. Okay, so if s length is 10 power 4, n square will become 10 power 4 into 10 power 4, which is 10 power 8. And if you are following my playlist, in every video I talk about if your code is actually nearly to 10 power 8, your code is safe. Okay, sometimes 4 into 10 power 8 is also safe, 5 into 10 power 8 is also safe, means you will be able to submit the code. The only thing is it will be slow. Okay, but in such case you have to optimize. But if the code goes beyond 10 power 9 or 9 into 10 power 8, 8 into 10 power 8, that will give you TLE. So in total, just you have to see if in the constraint 10 power 4, so n square will become 10 power 8. It will be slow, but you have to optimize. Means in both the cases you have to optimize, either 10 power 8 or 10 power 9. 10 power 9 will give you TLE for sure. So in both the approaches you have to optimize. The only thing is you should be aware of when the code will give TLE and when it will be slow. Okay, so let's write the code for this. I have already written the code for this. First you will make a string builder. You will convert the string into string builder because string is immutable in Java. Okay, we'll initialize the I pointer and we will run the while loop till the second last index, sorry. Why? Because we are reading I and I plus 1th character. Okay, so we'll read the both characters, and in if cases we'll check if the ith character is open and I plus 1 is from close, and that too from the same family. Okay, so either of these 3 brackets found, you can say yes, we found. So we can delete that. Correct? So we'll delete, like there are 2 ways to delete. sb.delete char, like you can delete character by character at 2 indexes, or else you can delete in a range also from I to I plus 2, because I plus 2 is always excluded. So I and I plus 1th index will get deleted. Okay, and what we'll do once deleted, we will go back only if ith location was positive. Remember, if I is already pointing to 0th index, means there is no such element left over, so we'll simply do I plus plus. Or else if I is 1, means for sure at 0th location we have something which we definitely want to compare with the next one. Correct? So hence we'll do I minus minus only if I is positive, and if any such character is not found, so else definitely we'll do I plus plus. Okay, at the end if our string length is 0, then only we can say return true, or else we will return false, right? So definitely we can run this code. Okay, and we can submit this as well. So as you can see, it has been submitted. So let's see the optimized code now. So in this question, what we are doing, whenever we are finding any such open bracket and matching with the closing bracket, okay, we are deleting. Okay, in optimize we will not delete, we'll see what we'll do. But after that, what we are doing? We are going back. Why? Because now we want to look for the closing bracket for this pair, correct? And see what if it matches going ahead. So similar thing we already did in the previous pattern as well. That was undo operations, if you remember. Okay, if not, definitely I'll recommend you to go and watch that. So whenever we move back to find pattern, or we go back or ahead to find the maximum or minimum, we always go or opt for stack data structure, correct? Here also we'll do the same. So the idea is very simple. As you found a open bracket, so like when we are trying to match, when we find a closing bracket, correct? Okay, found a closing bracket and now I want to check the open bracket. Okay, don't get confused. In the brute force we talk for open, we are finding close. Both are same. In brute force also you can say, like earlier we were doing I and I plus 1. In the brute force also you can say ki if ith character is a closing bracket, then I minus 1th character should be open bracket. I hope you're getting my point. Okay, so like this, both ways works. So what I am saying now, for every open bracket, like open, in brute force also what you did, once you find this closing, you delete it, correct? But you already saved this open bracket somewhere so that you try to match with the closing one, correct? So what I am saying, idea is very simple. Once you found a open bracket, just insert in the stack. Second, again insert in the stack. Third, insert in the stack. Why? Because all are open brackets. Now the moment you hit the closing bracket, so your current character is a closing bracket. Now what are the false condition? Like when can you return false? Thing is, if the stack top element is, definitely we are only inserting open, so definitely it will be open. But if it does not belongs to the same family, we can return false then and there. Means suppose this is open but of small family and this is square bracket, so definitely they do not match each other, so we will return false then and there, correct? But in this case it matches, so what we'll do, we will pop from stack. Anyhow closing brackets are not going in the stack, so no worry. Okay, now next time curly open bracket, so that we will add. Now next time curly but closed bracket, so we'll again check from the stack top, both are matching, we will pop from the stack and we'll move ahead. Now we found a closing bracket for what? Smaller bracket, and the stack top element is having open, means valid pair. Again we will pop and we will not consider anyhow the closing bracket into stack. Now we'll move to the next. It is open, we will insert. Now we'll move to the next. It is closing, so definitely the top element is open, so we will pop. Again we'll move to the next. It is closing, top element is open, so we will pop, correct? And we'll go out of the index. Now as the stack is empty, so we can say it is a valid pair. Okay, why it is important? As if you remember in the brute force, string, like it needs to be empty, correct? Suppose second example, in short, you have open, open and close. So definitely you will put open, and the moment you hit close, for this you found open and you will go out of the index saying everything covered. But in stack you have an open bracket, right? For which you should have a closing bracket, but you don't. So if at the end you have something in the stack, so you will say this is not correct pair, so you have to return false because this is not valid string. Now similarly, one more condition. What if you have closing and then this? So first you found closing. So for this closing, you should have open bracket earlier. Means you will go and check in the stack, but your stack is empty. Means you can say you can return false then and there. Means either if going forward everything is valid, but as this is not valid, so you will save your rest over time, correct? You will return false then and there, correct? So now let's write the code for this. Definitely the time complexity will be only O of n, because you are just iterating on every indexes one by one, correct? And you are just putting in the stack, so obviously for stack also O of n space complexity. Okay, so let's write the code for this. First we will make a stack of type character. Let's name it stack is equal to new stack. Okay, definitely you will run a for each loop of type character ch from s dot to character array. We have to change in a character array because we want to read every character one by one. Okay, so we have to check if the current character is open. Okay, so if the current character is open, then we'll simply put in the stack, right? And if not, then we have to match, correct? So there are multiple ways to check if the current character is it belongs from a closing family or not. So for that, you can either write different if-else cases, but I am going with a map where I'll save all three pairs. Why? Because I already know there are only three pairs. So anyhow, the space complexity for map will be O of 3, which is constant, right? So I'll make a map and there I will save, both open and closing bracket, so it will be of type character. Name it map new hash map. Okay, done. And I'll put the pairs, like, you know, brackets in the map. So map dot put, first I will put closing. The reason I'll tell you why. I want, like, you know, in a map, whatever is the first is the key, right? And when my current character is a closing bracket, I want to search with the help of map dot key, okay, if it contains. So that is the reason I'm putting the, you know, closing bracket first and then open bracket. Okay, so this is for smaller bracket. Now I will do the same for curly, closing, open. Similarly, square, closing, open. Okay, now what I'll do now, if my current character is closing, so definitely my map contains that key ch, and if it is so, means the current character is closing. So I will check the conditions. If not, if it is open, then definitely I'll simply push in my stack the current character. Correct? But if it's a closing bracket, definitely we have to check two things. Very first is ki, what if current character is closing but we don't have anything in the stack? So we will write the two false conditions. Okay, very first is ki, what if my stack is empty? Then definitely we will return false. Or else the second false condition is ki, what if we have the open bracket but like we don't have the matching pair? So how we'll check ki, if stack dot pop means top element is not matching with map dot get this, you know. So that's why we have written this, you know, closing bracket first. So for this closing bracket, we'll get the value which is open bracket, and if that stack top is not matching, we can definitely return false then and there. Correct? And after coming outside, we can only return true if our stack is empty. Correct? Yes. So that's it. This is a simple code. We can run this, and the time complexity is definitely O of n. Space definitely. Did I miss something? Okay, sorry, I have inserted, you know, hard-coded here. We have to read as per the character, okay? So, time and space both are O of n, O of n. So, now we can submit this, and this was your, you know, optimized code. So, this is the optimized code from Java, and here is your optimized code in Python, if you guys are from Python background. And here is your optimized code for C++, if in case you guys are from C++ background. And with this, if you understood the brute force and optimized code, then you are eligible to go in the sheet and mark the very first question as done. Okay. And I hope you will submit this on your own, you know, just like you won't do any copy paste, and you will write the code from scratch on your own. If you're doing for the first time, definitely I'll recommend you to do the dry run. See and write different test cases, you know, with different brackets, with different scenarios. That's how you learn, and that's how we all learned. And that's it for this video, guys. If you like the explanation, please hit the like button, and please subscribe the channel if not yet subscribed. What are you waiting for? And if in case you guys are new to this channel, we are following the pattern-wise DSA sheet. You can get the link from the description. And if you guys are watching till now, I'm available on social medias like Instagram, LinkedIn a lot. You can follow me there and reach out to me in case of any guidance. All the links of the social media I'll add in the description. And with this, let's wind up the session. Let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family.